Hello, good morning all. Is my voice
Good
audible?
morning.
I'm just checking,
Mm-hmm.
ma'am, whether it's audible and
Audible,
clear.
Kumar. You can go ahead.
Okay, ma'am. Okay, ma'am.
Yeah,
So,
audible,
good
audible,
morning.
audible.
Okay, good morning. So, today we'll be continuing our previous class session topic. So, advanced process. So, I hope you remember in previous class we started with 80186. As I said, 80186 is nothing but your improved version of your what? 8086. So, improved version in the sense it has what? Faster instruction execution time and a few more instructions and compared to what? 8086. Additionally, it has certain features added inbuilt on the chip, like your DMA controller, interrupt programmable interrupt controller, programmable timers, programmable chip select logic. So all this has been what incorporated in this 80186 process, and speed has been increased. Okay. So now we'll move on to your second type of your another uh, processor, high advanced processor, 80286. Okay. So as I said earlier, 80286 was introduced in the year what? 1982. Okay. And almost the same year, 80186 and 80286 almost same year. And it's also known as what? IAPX286 processor. And it's this 80286 processor is an 16-bit microprocessor with having so approximately 1,34,000 transistors inbuilt within the chip. Okay, so imagine so what the technology they would have used to fabricate so much of transistors within a single chip. So approximately 1,34,000 transistors are inbuilt in this processor. And then, and one of the features is it is the first Intel processor where you could run all the software written on the user. So, and the clock frequency, initially, if you say initially the clock frequency of this 80286 processor, it was released with 6 and 8 megahertz, but later it was being subsequently scaled up to what 12.5 megahertz. So, which means if you calculate the average speed and also the performance is the frequency of your CPU. Okay. So I'll see in detail about this in later. Okay. And then and one more thing is if we compare 80186 and 80286, 80186 has on-chip clock generator, but there is no on-chip clock generator here in 80286. So which means the externally some clock chip has been used. So externally, if you see, means 82284 chip is required. Actually, they are using 82284 chip to generate your external clock. Okay, and fine. So and one more feature that you can remember is 80286. No, it operates in two different modes. As I said, one will be a real mode, other one is a protected mode. Okay, so in real mode, it will act similar to your what 8086 processor, whereas in protector mode, you'll be having a for enhanced. You can use 80286 enhanced mode. Like we'll be having memory management, multitasking, protection. All these features will be added. Okay, fine. So now we see the architecture of this 80286. So just have a look at the architecture of 80286. So already we have gone through this. I'll just summarize it very quickly. So just by the look, you can be able to understand that the processor 80286 processor is little advanced and a high performance microprocessor. So we'll be having certain optimized capabilities for performing your multi-user and multitasking systems. Okay, and almost 80286 it is compatible with your 8086. That is common. So if you see the internal block diagram architecture of 80286, will be having what these 4 function units. You can just look at the block diagram. So you'll be having 4 important function units. So one is your address unit, other one is your bus unit, instruction unit, and then execution unit. See, just make a note of all the blocks which are present inside this units, individual units, so that you can able to understand much more easier. So execution unit, address unit, bus unit, and instruction unit. Okay. So these are the 4 units available in 80286 processor. So first we'll start with 80286 address unit. So okay. So what is the function of address unit? Normally, so in any processor, whatever processor you take, so what will be the function of your address unit? Even in 8086 we saw. So the main function of this address unit is used to, normally the address unit, it is used to determine the physical address of the instructions, and even not only instructions, even operands, physical address of your operands, so which are stored in memory. So the address unit computes your 20-bit physical address. So with the help of the contents in your segment register, and with all together with your 16-bit offset, similar to your 8086. Okay, so same way how you used to calculate the physical address in 8086, the same procedure you are able to follow for 80286 also. Okay, so the address lines, they are derived from the mainly it is derived from your address unit. It can also be used to address different peripheral devices, maybe memory, such as memory, or even IO devices. All this also your address unit takes care. Okay. Okay. So these are the functions of your address. So so as I operations. So in addition to this, it also contains, if you just look at the block diagram, the bus unit consists of latches and drivers. Okay, well, usually these latches and drivers are needed to demultiplex your address and data bus. Okay, so for that purpose, we need these latches and drivers. And apart from this, the bus unit is also responsible to fetch the instructions bytes from the memory. So generally, generally what happens, the instructions will be fetched in advance. So actually the same concept, fetched instructions will be stored in a queue for faster execution of the instructions. So and this concept only called as instruction pipelining. It is mainly be followed to increase your increase your speed or reduce your execution time. Okay, total execution time. Okay, So which means by doing like this, what so by fetching the instructions, the CPU will not wait till the completion of the execution of your previous instructions. Okay, so because while one instruction is being currently being executed, the subsequent instruction will be pre-fetched, it will be decoded, and it will be kept ready for what execution. So for this we use so we have a prefetch and modification. Prefetches instructions mainly to the purpose of what? To enhance your speed, execution speed. Okay. So all these are taken care by your bus unit. And moving on to instruction unit. There will be continuity from a bus unit. Actually, there will be continuity to instruction unit. So the 6-byte prefetch queue, or instructions stored in the 6-byte prefetch queue. So it forwards those instructions sequentially to your what? Instruction unit. Okay, so this instruction unit, what it does means it receives the instructions from the prefetch queue, and the instruction decoder which is present in this instruction unit, it decodes them one by one. So after decoding the decoder instructions, they will be latched into what? A decoder instruction queue. We have a decoder instruction queue. So the maximum capacity is the instruction decodes three prefetched instructions, and it loads them into what? Decoder instruction queue for execution. So it will be moved to the next stage for into the execution unit for further process. Okay. So next will be what will be function in execution unit. So the output of your decoder instruction queue to be fed to the a control circuit of the execution unit. So here this unit will be responsible for executing the instructions which are received from your decoder instruction queue. So apart from this, your execution unit also consists of what? Register bank, so for mainly for temporary storage of data. At ALU, arithmetic and logic unit. And it also has what? Control block. So data. Okay, it's storing the data, and followed by so a special function. It's actually the register bank. It also can be used as special function registers like accumulator. So those and all can be used as for special function registers, special purpose registers. And ALU, it's nothing but the core of your EU. So because it is a place where it will perform all the arithmetic and logical operations, and the results will be sent over the database to the register bank. Okay, after the end of the operation, so the results will be sent to the registers with the help of what? Database. And the control block, as the name indicates, what it controls the overall operations of your taking place in the execution unit. Okay, and okay, so these are all basic blocks. We have seen in detail about basic blocks. Now we'll see what are the register specs available in 80286. Okay, fine. Actually, 80286 architecture, if you see, means we have what? 15 registers. So all these 15 registers can be grouped in either one of these four categories. So general purpose registers, segment registers, base and index registers, and status and control registers. So well, first we'll start with general purpose registers. Okay. So as I said previously, 80286 has 16-bit data bus. So which means all the registers will also be what? 16-bit in nature. Okay. So here we'll have here in this 80286 we have what? 8 16-bit general purpose registers. So these you can use these registers to store arithmetic and logic operands. Okay. And Okay, so these you can use it as pairs of and you can just look at the other resistors also. Segment resistors available, status and control resistors also available. So all are similar to your what 80 to 86 sorry 86 processor. Okay, so moving on to segment registers. So nothing much to say about segment registers because it is almost same as your what 8086. So here we have what four 16-bit special purpose registers. So which are used to what select the as the name indicates, these are registers are used to select this segment memory. We have
Kalyan Kumar, voice is breaking. Kalyan Kumar,
all the slides. Ma'am? Yes, ma'am. Actually, I'm verifying the same through phone, ma'am. Because when I change the slide, it's not the same thing is not happening here
okay,
by phone. That's why I'm verified, ma'am. Okay, ma'am. No issues. Ma'am.
okay.
So moving on to your base and index registers, okay, same as your 8086. We have what? So four of the general purpose registers can also be used to determine your offset address of operands in memory. These base registers, control registers. So here we have what three 16-bit special purpose registers. So these registers are, as a name indicates, status and control registers. They are used to what record and control the operations, the results of the arithmetic operations in happening in 8086 processor. And apart from that, we have a instruction pointer. So the main purpose of instruction pointer, so program counter, also called as program counter, contains the offset address of the next sequential instruction it has to be executed. Okay, and we have a flag description. So next one, something called new called machine status world. See what is maybe machine status world. The help of so, moving to flag description. So it's record. Just a minute. Okay, ma'am. Okay, ma'am. Now I think it's actually slide. It's taking nearly around 40 to 50 seconds for the slide to change, ma'am. Actually, I changed the slide long
Okay,
back,
okay.
but
Okay,
it's taking time now. So that's why I paused for some time.
Hmm. Okay.
Okay. Okay, ma'am. I'll continue. So next is you can just look at the program status code for 80.286. So I think almost same. If you see the lower 16 bits of your flag status word, so I think everything is almost same. Carry flag, a parity flag, auxiliary carry, zero, sign flag, trap flag, interrupt flag, direction flag, OF overflow flag, and this is something called new IOPL, input output privilege level, and nested tasks. So these two alone are something new to you. And below is the diagram for a mission status word. I said something called mission status word, here, which means here we have only what 4 pins as active. I'll see what is functions of these 4 pins. So there is something introduced newly in 80286, so not available in a previous process. So carry flag. So obviously you know what it is. The carry flag will be set to high when there is a higher order carry or borrow. Okay, otherwise it will be reset. And parity flag, as the name indicates, if the result of your lower 8-bit contains an even number of ones, this bit will be set, otherwise it will be cleared. Okay, and then auxiliary flag, which is nothing but your D4. So which means again when there is it will be set when there is a carry or borrow from to the lower order 4 bits of your arithmetic instruction AL operation. Okay, otherwise it will be set. So zero flag. So if the result of any operation is zero, it will be set. Otherwise it will be cleared. Sign flag. So sign flag, no, it will be set to 1 if a higher order bit of the result. Okay, is set. If it is 0, if it is positive, and 1 if it is negative. And then we have something called overflow flag. Overflow flag, it will be set if there is too large positive number of too small negative number without including your sign bit is to be fit in a destination operand. Otherwise you can clear it. So your status flags 86 and nothing new. So in the trap flag, so once this trap flag is set, we'll be having it interrupts into what single single step interrupt takes place. So which means each and after execution of each and every instruction, a single step interrupt occurs. Okay, so you can clear this trap flag with the help of this single step interrupt. And we have something with the D9. If you see interrupt flag, so when this flag is set, mask play interrupts will cause state location, and it causes your mainly to direct auto increment, auto decrement, or auto increment depending upon your direction flag value. So if you set the direction flag, auto decrement takes place. If you clear the direction flag, auto increment takes place. So all this here comes under your program status word. So moving on to your mission status word, so MSW, we have something new called. So here if you see So we have PE, 16286 will be replaces it in production mode. It works in production mode. Okay, so if you want to clear this production mode, the only way you can do is you can clear by resetting the CPU. So I repeat, when production PE set, your 80286 will be set in production mode, and you can clear this production mode bit with the help of by resetting your CPU. And bit 17, D17, something called MP. So we call it as what? Monitor processor extension flag. Okay. So when this MP flag is set, so which means the monitor processor extension flag, no, it allows the wait instruction to generate a processor extension, so which is not present in the exception. Okay. And we have some EM, so bit D18. So EM, okay, EM. So the main so EM stands for what? Emulator PU. And last bit is your TS, task switch. So when task switch is set, the flag indicates that the next instruction using the extension will generate what? Exception. Okay, so thereby permitting the CPU to test whether the current process extension is for the current task or not. So these are the 4 different types of machine status words newly introduced in 80286. Your 8086, 286 it is not mentioned, but you can make it fine. See, before just discussing about this addressing modes, I just want to mention this: what are data types 80286 can support. So actually, it's strings, ASCII, packed BCD, and normal BCD, and floating points. All these are supported by your 80286. So when I say integer, it can be assigned a binary numeric value. It can be either 8-bit byte or it can be 16-bit word. Okay, and then ordinal means nothing but your unsigned numbers. Okay, so ordinal is nothing but an 8-bit or 16-bit unsigned binary numerical value. We call it as what? Ordinal. So it also 8028 also supports what? Ordinal type of data. Pointers. So you know what you mean pointer. String. So a sequence of bytes or words. So a string, no, we can from 1 byte to 64 kilobytes or allowed. And as so byte represents CD from this 8026 addressing modes. So if here in this case, I think initially when I was discussing about the features, I mentioned you 80286 microprocessor operates in 2 different modes. What are the modes? Do you remember? So when I was discussing our features, I was listing about the features. I just mentioned this. 80286 microprocessor, it operates in what? 2 different modes, I said. What are the modes? You can just post your answers in a chat box. So one will be your real address mode, and second one will be a protected virtual address mode, PVAM. So these are 2 different modes available in 80286 processor. So what do you mean by real addressing mode means? So in case of your real addressing mode So 8086, no, will be 6 address. So your 80286, okay, will have an array of what, up to 1 MB of physical memory, and it will use the addresses from A0 to A19, and along with BHE, bus high enable. So all this so which means what I want to mention is, so when you are going to use 80286 in real mode, so it will work the same as your 8086 in a faster manner. Okay, and so as I said earlier, your 80286 has a 24-bit, it only has 24-bit address lines, but here we are using and the remaining no, 820 to 823 high-bit lines. That's what this flag is set. Obviously, what your 80286 will be placed in protected mode. So thereby you can enter in protected mode. Same is the case here. So when this 80286 enters into protected mode, so you'll be having certain additional features like memory management, production mechanisms, and all. Okay. So what is the difference from virtual mode and protected mode? Any idea we have? So okay, so here no, you'll be having an entire 16 GB available, whereas in case of a real mode, you'll be having only 1. But in this case, we have so with this, your 80286 is over. So just we'll have a comparison between your 80286 and the 8086 processor. So any a few differences that you have noticed between 8086 and 80286 processor, you can just mention. 16 in So any differences between 80286 and 386, 8086 and 80286? At least you can state the major differences between 8086 and 286. So you can just at least mention some 2 or 3 differences, major differences between 8086 and 80286 processor. See, am I audible or not? Usually I get the answers from a few people, even those students are not responding today.
சார் வாய்ஸ் பிரேக் ஆகுது, அப்புறம் திரும்பியும் கிளியரா இருக்கு சார்.
அது நெட்வொர்க் ப்ராப்ளம் ப்ரோ, அதான் பெரிய இஷ்யூவா இருக்கு.
இப்போ கிளியரா இருக்கு சார், இப்போ நீங்க பேசிட்டு.
அதான் ப்ரோ, ஒன்று ஆக்சுவலாக என்ன இருக்குன்னா, டவர் நல்ல பாயிண்ட் சிக்னல் ஸ்ட்ரென்த் அதிகமாக இருக்குது, திடீர்னு கம்மியாயிருது. அது என்ன பண்ணான்னு தெரியல. இத்தனைக்கும் வீட்டு வாட்ஸ்அப்ல தான் உட்காந்து நடத்திட்டு இருக்கேன், இதுக்கு மேலே எங்கே உட்காருது. So anyway, I can just compare 8086 with 80286. So I can say that 80286 is advanced version, or not advanced version, improved version of your 80186. So whenever say improved version, the sense that what a faster instruction execution time, and we'll be having a few more instructions added. Okay, and then what all points you can say. So same case here also we have what high speed DMA channels, program interrupt controllers, timers, all these are incorporated in 80286. Okay, and you can just discuss about the frequency, clock frequency. So there it is 5 to 10 megahertz. Here it is from 8 to what 12.5 megahertz. And so in 8086 we don't have a production mode and all. So here we have protected mode. We have protected virtual address mode option available, and 8086 has what 20-bit address lines, which means you can able to access up to 1 MB of memory, physical memory. Here we have 24-bit address lines, so which means you can able to access what 2 per 24 what almost 16 MB of physical memory. So this is the point you can just mention. And then and regarding the power consumption, so almost, so when compared to 8086, all of the advanced process consume what? Power and please, so no doubts in 8086, you can just let me know. So I again repeat, so just go through the be thorough with the architecture of 8086, because from that only all this process has been developed. So we'll be having certain additional features being added on as we go, higher and higher and higher. So 1 or 2 certain features will be keeps on adding, and rest everything will be what is same. So if you see here in 8086, for example, in 8086 I said I have 2 modes, real, protector. Here we have additional one more mode called virtual. So that it keeps on what be adding. So rest the basic units will be remains the same. So if you have questions, you can just post questions.